This video is about finding the rate of change from a table, graph, or function rule. So yesterday we explored motion graphs. Today we are going to use graphs and tables to determine a rate. The most important idea from today's lesson is that the rate can be found from both representations. So in this graph we have two parts. We're going to call the first part A of our graph, the second part B. In part A, our line is increasing. It's kind of steep. And our distance is getting larger because we went from 1 to 7. So in this part, we are going to say that we are moving fast and away. In part B, our line is a horizontal line, which means we're not moving at all, so we are stopped. Now we're going to actually determine how fast we're moving in each section. So if we look at the graph, there are 3 points for A. So 1, 2, 3. We're going to write those 3 coordinates in the table. So the first coordinate is at 0 seconds, we're at 1 feet. At 2 seconds, we're at 4 feet. And at 4 seconds, we're at 7 feet. So now we're going to figure out what our rate of change is. So in order to do that, we want to see how are we changing in the distance compared to the time. So in the distance from 1 to 4, we added 3. And from 4 to 7, we also added 3. In the time, from 0 to 2, we added 2. From 2 to 4, we added 2. So our rate of change then is the change in the y coordinate compared to the change in the x coordinate. So we have 3 over 2, and then we're going to use our units, so feet per second. If we go up to the graph and look, I'm going to make a little triangle with 2 of the points. So to get from 1 to 4, we went up 3, and to get from 0 to 2, we went over 2. So this is going to be the same for a rate of 3 over 2 feet per second. So now let's look at segment B. So in segment B, we have these points that are at 4 seconds, 6 seconds, 8 seconds, 10 seconds, and 12 seconds. Notice that at each of the seconds, we're still at a distance of 7. So when I go to fill in my table, I have 4, 6, 8, 10, and 12. My distance is always at 7. So if I want to see how did I change from 7 to 7, I added 0. I didn't change at all. But with my time from 4 to 6, I added 2. Or from 2 to 8, 8 to 10, 10 to 12. So my slope here is 0 over 2. 0 divided by any number is 0. So we would have 0 feet per second. Anytime that we have a horizontal line, we are always going to have a slope of 0, because here we went over 2 seconds, but we didn't go up at all. So we still had the rate of 0 to 2, which is 0 feet per second. So anytime that is a horizontal line, our slope is going to be 0. So as a reminder, to find the rate from a table, we are going to do the jumps in distance over the jumps in time. To find the rate of change, we're always going to do, in this case, if we're looking at the 2 units, we're going to do distance over time, which is going to be our rise over run. So our units might change. Instead of feet per second, it might change to dollars per person. It just depends on the situation of the problem. Whenever we do this, we're always going to go up and over. However, sometimes the line is also going to go downhill. And if the line is going downhill instead of uphill, that means our rate is going to be negative. So let's look at another situation. So in number 4, we want to fill in our table. So we have these points that are given to us. So at 0 seconds, we're at 8 feet. At 4 seconds, we're at 6 feet. At 8 seconds, we're at 4 feet. At 10 seconds, we're at 3 feet. And at 12 seconds, we are at 2 feet. So if I want to look at my change, now notice that the table is not going up or down by the same numbers this time. So if I look at my distance, I am decreasing. So instead of adding, I'm going to subtract. So here I would subtract 2. Here I would also subtract 2. However, in the last two, we are only subtracting 1. When we look at our time, the first ones, we are going to add 4 seconds to the first two, and then we're only going to change by 2 seconds. So when we do the rise or overrun, we need to take it from the same row. So we have two different ones. We have negative 2 over 4, which reduces to negative 1/2, or we just have negative 1/2. So our rate then is going to be negative 1 over 2 feet per second. Okay, if we look at the graph, we can also see from here to here, we went down 2 over 4, which gets us the slope of negative 1/2 when we reduce. Same thing in this triangle. We went down 1 over 2. So every time we're going to end up at the same rate, because remember, you always need to reduce. So when I look at the graph this time, is the rate constant? Okay, well, the rate is constant because the line is straight and you always get the same rate. Notice on this graph, though, that because it was negative, we moved down and over instead of up and over. This is because the line is going downhill. Here's another graph that shows Terrence's movement while he's skateboarding. Can you read the graph to complete the puzzle about the different rates of change you see on the graph? So in number 3, segment blank shows a rate of 0. Remember, a rate of 0 is a horizontal line, so that's going to be segment B. Segment blank shows a negative rate, so that means the line is going to be going downhill, so that's A. And segment blank shows a positive rate of change, so that means it's a line going uphill, so that would be C. Then for segment A, we want to find our rate of change. So how much did we go down and over? So we went down 4 over 2. So negative 4 over 2 would simplify to negative 2 feet per second. In C, we went up and over. So we went up 2 grid lines and we went over 5. So our slope here would be 2/5. In this graph, notice that our line is curved, which means that it is not constant because it forms a curve instead of a straight line. But this is something that we will talk about later on next semester. So here's another graph that shows Terrence's movement while skateboarding. Can you read the puzzle to test your knowledge of understanding rates from a graph? So in segment A, the rate of change is, well, in segment A, because it's flat, our rate of change is going to be 0. In segment B, this indicates that the rate of change is constant because it's a straight line, and because it's going down, that means it's going to be negative. In section C, we can see that it's a flat line, or a straight line, so it's going to be constant, and it's going to be positive because this line is going up from left to right. Segment D and E, those are kind of curved, which means our rate of change here is going to be not constant for D, but it is going to still be positive because it's going up. And for E, it's going to be not constant and negative because it's going downhill. according to the graph, Terrence is moving blank during the time in section B compared to C. So in B, our line is steeper, so he is moving faster in B compared to C. In number 6, we want to match the graphs with the given situation. So this is why we talked about before connecting and not connecting our lines. Okay, so in number 6, match the graph with the following situation. Michael spends begins with $25 and spends $5 each week. So once a week he's spending $5. So our line should be going downhill, but it should be dots because he's only doing it once. It's not a continuous thing. The next one, Tara buys 1 box of mac and cheese each week. So each week when she goes to the store, she gets 1 box. So our line should be going up, but it should also just still be dotted. Mira runs to the mailbox, moving away from the house. So if we start close to the house and we move away, that's going to be C. Jose slowly jogs towards the finish line. He stops to rest before he gets there. So he's moving towards the finish line, but then he stops. That's A. And Margaret stands and watches the sunrise, or the sunset, so she is not moving at all, so that is going to be E. In number 7, let's find the rate of change. So now instead of our table being vertical, it's horizontal. So we're still going to find the rate of change. Remember, we said it's going to be the distance over the time. So if we look at the distance, the first box from 6 to 10 increased by 4. The next one increased by 6. The next one increases by 10. And the last one increases by 4 again. If we look at our time, we increase from 2 seconds, then by 3 seconds, then by 5 seconds, and then back to only by 2 seconds. If we look at our rate of change, and we can do all of the different numbers. So if I have 4 over 2, that reduces to 2. 6 over 3, that reduces to 2. And 10 over 5, that reduces to 2. So because they all reduce to the same thing, our rate is going to be 2 feet per second. And because it's positive, this would mean the line is going uphill. Because of the positive rate. In number 8, we want to find our rate of change. So in letter A, our line is going down and over. So from 8 to 1, we went down 7, and from 0 to 2, we went over 2. That's going to be negative 7 over 2 feet per second. In B, it's a flat line, so that's going to be 0 feet per second. We're not moving at all. In C, we went up 2 and over 2. So our rate is 2 divided by 2, which is 1 feet per second. D is also flat, so that's going to be 0 feet per second. And our last section, E, we went up and over. So we went from 3 to 10, we went up 7 and over 1. So we have 7 divided by 1, which is 7 feet per second.